We're going through a complete explainer on mastering CLAT Quantitative Techniques. But hey, forget about abstract, mind-bending algebra. Today is all about solving actual, real-world problems. We're going to build up your data reading skills and, most importantly, we're going to learn exactly how to spot the traps those test makers are setting for you. Okay, let's dive into this.
So, here is our game plan for today. We're going to start by really defining what real-world problem-solving actually looks like. Then we'll tackle a business budget to absolutely master percentages, learn how to dodge those sneaky percentage change traps, and break down a classroom scenario using ratios. Finally, we'll pack all of these triumphs into your ultimate problem-solving toolkit.
All right, first up, real-world problem solving, and why we need to completely move beyond abstract math.
Seriously, if you've been having cold sweats about calculating the exact trajectory of a train leaving a station at midnight, take a deep breath. You can totally relax. The CLAT Quant section is 100% data-based. There is absolutely zero pure abstract solve for X arithmetic. None. Instead, it's entirely testing your ability to read and interpret data from short passages. It's about practical comprehension and making sense of the numbers in front of you, not memorizing complex, confusing formulas.
You aren't going to be staring at a blank page of random equations. You'll be looking at excerpts that read exactly like the news you consume every day. Stuff like gender wage gap statistics, household budget breakdowns, or survey data. You already navigate this kind of information, so you absolutely have what it takes to solve these. Let's move into our next focus, mastering percentages and profits, using a classic business budget case study. Let's put this right into practice. Imagine a small business and they bring in a total monthly revenue of exactly 1,200,000 rupees. Take a look at how this budget breaks down. 35% goes to raw materials, 20% pays the staff salaries, 15% covers rent, and 10% goes to marketing. Whatever is left over, that's the profit. And this brilliantly illustrates how the test presents information to you. The data is all sitting right there, but you have to actively engage with it to find that visually missing slice of the pie. So how do we find that profit? Let's think aloud and walk through it exactly like a master problem solver would. Step 1 is super straightforward. We just consolidate what we know, add up all those stated expense percentages. So 35 plus 20 plus 15 plus 10, that gives us 80%. That means 80% of the revenue is already spoken for. Step 2, find the remainder. The whole is always 100%, so 100 minus that 80 leaves us with a neat 20%. The business saves 20% as profit. Step 3, calculate what 20% of that 120,000 rupee revenue actually is.
Boom, there it is. 20% of 120,000 rupees is 24,000 rupees. Just by reading the data logically and taking it step by step, we easily and accurately extracted the correct figure. See? You're already solving real-world problems.
But don't get too comfortable just yet. Now we need to talk about avoiding percentage change traps, specifically what we call the plus 20 red flag. Okay, lean in for this one because here is where things get a little tricky. Test makers love, and I mean love, to set psychological traps. They know exactly how our brains want to take the path of least resistance. Let's use the exact same business from our last example. The revenue and all other expenses remain totally unchanged. But what if the rent increases by 20% next month? What is the new profit? Think about how you'd instinctively solve this right now.
Be honest, was your first instinct to just add 20 to the 15% rent slice we saw earlier, suddenly making it 35%? If it was, stop right there. That is the trap. The test makers are banking on you confusing a 20% increase with adding 20 percentage points. And guess what? They will absolutely put the result of that wrong calculation in the multiple choice options because it looks so numerically close, it feels right. The correct solution? You have to calculate a 20% increase on the specific base figure of the rent itself.
Let's break down the actual math so you can defeat this trap every single time. Step 1, we have to find out what the old rent was in actual rupees. It was 15% of our 1.2 lakh revenue, which equals 18,000 rupees. Step 2, the rent increases by 20% of itself, right? So 20% of 18,000 is an extra 3,600 rupees. So the crucial point is that this extra cost has to come from somewhere, and since the revenue is completely unchanged, it's coming straight out of the profit. Step 3, we just subtract that extra 3,600 from our old profit of 24,000, which leaves us with a new profit of 20,400 rupees. By staying structured and identifying the correct base figure before doing the math, you completely bypass their trap and land safely on the undeniable truth of the data.
Let's move on to our next section, solving ratios and averages using a classroom case study. We're leaving the business budget behind to see how these exact same traps appear in demographic data. Here's a scenario straight from the source. We have a class of 40 students. The ratio of students who chose science to those who chose commerce is 3:2. The average marks of the science students on a recent test is 78. The average marks of the commerce students is 68. The question inevitably asks, what is the average marks of the entire class?
Red flag time again, folks. The absolute most common mistake here, the wrong shortcut, is to just look at those two averages, 78 and 68, add them together, divide by 2, and confidently click 73. No, that straight average completely ignores a massive piece of data, the unequal group sizes. Because the ratio is 3:2, there are physically more science students in that room than commerce students. You can't treat the groups equally. We absolutely have to use a weighted average.
Now, what's really interesting about this slide is how quickly a confusing ratio turns into simple, manageable numbers the second you organize it. We split our 40 students into that 3:2 ratio. That gives us exactly 24 science students and 16 commerce students. To find the total marks for each group, we just multiply the number of students by their group's average. So 24 science students times their average of 78 equals 1,872 total marks. 16 commerce students times 68 gives us 1,088 total marks. Suddenly, everything is perfectly concrete.
To find the true average of the entire class, we just walk through two final, easy steps. First, we combine the total marks from both cohorts. 1,872 plus 1,808 equals 2,960 total marks for the whole class. Second, to get the final average, we take that combined total and divide it by the total number of students, which we know is 40.
And that gives us our true class average, 74, not 73. It might seem like a really small difference, but remember, the multiple choice options will be designed to be incredibly close. By respecting the ratio and adjusting for those unequal group sizes, we arrived at the correct weighted average without breaking a sweat.
All right, let's bring it all home. Section 5, building your problem-solving toolkit to ensure triumphs over traps.
We have covered some fantastic ground today. Let's formally build this toolkit so you're ready for anything. Whenever you are faced with a data-based calculation, keep this 4-part framework top of mind. First, carefully read the passage to identify the right figure. Do not just grab the first flashing number you see. Second, always verify your percentage base. Are you calculating a percentage point increase or a percentage of the original number? Massive difference. Third, when you're dealing with averages, actively watch out for unequal group sizes and ratios. And finally, beware of numerically close options. They are almost always the result of those exact traps we just learned how to avoid.
I want to leave you with this final thought. The problem-solving skills we talked about today, they aren't just for passing an exam. They are literal frameworks for understanding the world around you. How can you apply these data reading skills to the news articles you read, the statistics you scroll past online, or even your own household budget today? Once you start looking for the real data behind the headlines, you realize that structured problem-solving is basically a superpower. Thank you so much for joining me on this explainer, and remember, keep questioning the data.
Just trying to wrap your head around the legal world a little bit better? Consider this your official invitation. Subscribe to Titiksha Legal. It is a space designed specifically for you to learn, question, and explore. Welcome to a much better way to navigate your legal journey. The path is absolutely yours to walk, but you don't have to walk it alone anymore. So what step will you take today? Just trying to wrap your head around the legal world a little bit better? Consider this your official invitation. Subscribe to Titiksha Legal. It is a space designed specifically for you to learn, question, and explore.